Hi, I'm Rich with insideHPC. We're here at ISC'14 in Leipzig, Germany, and today we're here at the Asetek booth, and I'm here with Steve Branton. Steve, how you doing today?
Good, how are you?
Oh, great, great. Thanks for having us here.
Pleasure.
Well, Steve, why don't we just start at the beginning? Who is Asetek and who do you help in this HPC space?
So Asetek is a liquid cooling company. We do data center liquid cooling, and we've been doing PC liquid cooling for quite a long time.
Oh, yeah.
We've in fact sold over 1.8 million liquid coolers over the course of the last 6 or so years. What we've done is then taken that desktop technology and evolved it into something that uses the same basic parts but works in servers, and instead of delivering the benefits that are delivered to desktop, overclocking, quiet PCs, what we do is use the technology to take the heat from CPUs, GPUs, and memory in an all-liquid path completely out of the data center.
Okay. So you got that long history of working with liquids and stuff and bringing that to a data center. So how's business going? I mean,
So that's really the exciting thing for us here at the show.
Yeah.
We've talked a couple of times about the technology.
yes.
What we're really talking about here this time is deployments. And we've gotten a number of them. We started with a deployment that we did at Lawrence Berkeley National Labs last year, where we deployed 38 Cisco units with Intel processors and did a variety of tests on those. Those have been put into a white paper that is now available on the Berkeley website to talk about how this type of hybrid liquid cooling performs, because we're cooling the CPUs, the hot parts, the CPUs and the memory, and then air cooling is used to take the remaining heat out of the building. That makes a very cost-effective implementation. It does have some interesting impacts on how that works, and the Berkeley paper really describes those very well. Then we've also installed here in Europe at the University of Tromsø in Norway. The University of Tromsø is the farthest north university. It's above the Arctic Circle. So free cooling at their location is no problem. But they also only get up to a high of 12 degrees C, which means you need heat all year long.
Yeah.
So one of the things that they want to be able to do is not work on their PUE so much as work on their ERE, or their energy reuse effectiveness. And the way they're going to do that is by using the heat from their data center to heat the campus buildings. Basically, it's a district heating application. So this chart is talking about how they're bringing in water, and they actually bring the water in at a very cold temperature, and they're able to warm it up to 42 C, and actually all above that, and capture about 70% of the heat, and then recycle that heat for heating the building, keeping the students warm, and the faculty.
Okay. All right. Yeah, sure.
So
Makes sense.
there's a paper here presented on this at the conference here at Leipzig. Another deployment that we're very excited about is one that Cray actually did with the University of Mississippi State University, where they deployed a 5-rack cluster. And Mississippi State's reason for wanting to use liquid cooling was that they had a limited amount of air conditioning in their data center. And in order to deploy more compute, they would have had to buy more air conditioning had they used traditional air-cooled system. By using a liquid-cooled system, they were able to take the CPU heat out and reject it into the air environment with just a dry cooler. Dry coolers are much less expensive than chillers, and so instead of spending money on infrastructure, they were able to actually spend money on compute.
On the supercomputing and add cores and everything they need. That sounds terrific.
Yeah.
Well, great.
And Cray's also deployed another system at Kyoto University in Japan. So we're getting some traction, which is very exciting.
Yep. Yeah, absolutely.
Yeah, so we've also deployed our first rack at Redstone, which is in Huntsville, Alabama. That's a program that we've talked about before with the STCP. The Department of Defense is working on saving energy like everybody else. Data centers are the biggest energy uses on many bases. And of course, there's other things the military would like to be able to use energy for. So by reducing their energy footprint there, they're able to defer energy to other locations and uses. The one thing that's exciting about that that's different than these is that's an enterprise data center. So we deployed 20 DL560s, HP DL560s, and that's a highly virtualized environment. With liquid cooling of this type, you want high utilization. Like an idling car gets lousy gas mileage, idling servers, liquid cooling doesn't help them so much.
Yeah. Great.
So we're doing that. And then, of course, we have our longest running installation, which is at the National Renewable Energy Labs in Golden, Colorado. That's actually been a cluster that's up and running for over a year now in production. And that was an upgrade of the Skynet cluster from an air-cooled data center into the new ESIF totally liquid-cooled data center there at NREL.
Okay. So Steve, as you get these deployments and you're more than proof of concept, this is production stuff going on. You see any slowing down in the growth of this? Because it seems like density and all that just going up in the HPC industry.
Yeah, we believe that this is going up, and as you've walked around the show, you've seen numerous people talking about liquid cooling. So I think that we're talking about something that's here to stay. I think from our perspective, what's nice to be able to talk about is the fact that we are actually deploying the system, and it is a system that's relatively easy to integrate and deploy in existing servers and with new servers like the Cray CS'300.